Hi students. So right now we're going to learn about how a vector can be represented as a matrix. Before that, we need to understand the meaning of word matrix. Basically, matrix is an arrangement. We call this as matrix is an array of numbers or elements in rows and columns. And we denote matrix with this round or square brackets. You can see that we have four numbers here, 3, 4, 5, 1. These numbers are arranged in two rows and two columns. So arrangement or array of numbers in rows and columns. These are rows, row 1, row 2, and these are columns, column 1 and column 2. So when we arrange numbers in rows and columns, that's called as matrix. And if a matrix is of this kind that we have only one column, for example, 4, -1. In this kind of matrix, you can say we have two rows, row 1, row 2, and there's only one column, column 1. So this kind of matrix in which we have more than one rows but a single column is called as column matrix. We can express or represent vector as a column matrix. That's what we're going to learn here now. And somewhere, suppose here is point B. I draw a vector from point A to point B. It is like this. So this is vector. I want to represent this vector from A to B, means AB vector, as a column matrix. That's the target. In vector AB, A is initial point, we discussed earlier, and B is the final point. So what we're gonna do here to find a matrix which will represent this vector AB, we're gonna move from A towards B, but first will be horizontal movement. When we move horizontally from point A, we can stop below B, right below B, we're gonna stop there. That's called horizontal movement. Horizontal movement is also called as run in coordinate geometry. Afterward, from this point, we're gonna go towards B. Now we have to have vertical movement. So it will move vertically up to point B. Okay, so now from this point, suppose this point is C. From this point C to B, there is a vertical movement that is called as rise in coordinate geometry. And that was the horizontal movement called as run. So how much is run and how much is rise basically can be utilized to represent AB vector as a matrix. Okay, I count the coordinates of this point A. So this point A is 1, 2, 3. It is at the third point on the x-axis, and C is at the 4th, 5th, 6th, 7th, 8th, 9th. Again, 1, 2, 3, A, 4, 5, 6, 7, 8, 9. And likewise here, 1 and 2. So coordinates of A is 3 on the x-axis, 2 on the y-axis. Coordinate of C is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on the x-axis and 2 on the y-axis. Likewise for point B, how much is horizontal? Horizontal is 9 like C. X-axis is 9 and y-axis will be 2, 3, 4 and 5. So 9, 5. Now we can say from point A to C, the 2 is same. The y value remains the same. So if you subtract the horizontal value, x value of C and A, that means 9 minus 3. If you take 9 minus 3, x value of C minus x value of A, you get 6 as a run. So this is 6 as a run. Likewise, when you move from C to B, you can see that the x value remains same, 9 and 9. But the y value changes from 2 to 5. 2 to 5. So 5 minus 2, which is 3, is the vertical movement. So when we move from A to B, basically we move x6 as horizontally and 3 vertically. So vector AB we can represent as a matrix, as a column matrix. Column matrix means one column, and in this case two rows. So one row is the x value run, or the x value is 6, horizontal movement 6. So this is first component, we call this as x value, means horizontal movement or run. Then there is a vertical movement, we call this as y value, y component, which is 3 in this case. So that's how we can write AB vector as a column matrix. The good thing is that when we write AB vector as a column matrix, we can find the magnitude or the length. So length or the magnitude of vector AB we can find by using Pythagoras, or in simple way, if you want to remember, if we are given AB vector as a column matrix 6, 3, 6 is x component, y is 3 is y component. So magnitude or the length of vector AB is given by square root of sum of squares of x component and the y component. So sum of squares of x component and the y component, basically it becomes 6 square is 36, 3 square is 9 square root, 36 plus 9 is root 45, which is equal to 3 root 5, or we can use calculator to find answer to 2 decimal places or 3 significant figures. So in simple words, the magnitude, we denote magnitude of a vector with AB vector modulus, or simply deleting this vector sign, just writing AB as a segment. So again, in this page we have learned how a vector, this vector in this case AB, can be represented as a column vector x and y, and then using that column matrix as a vector, we can find the magnitude or the length by this formula like this. Let's do some questions from the book. Here, exercise 9, this is from the textbook IGCSE 300 page. Question 1 to 12 refer the following vectors. So this is A vector, this is B vector, likewise other vectors. He's asking us to find number 4. Let's try number 4. 4 is magnitude of D vector. So magnitude of D vector by formula is square root of sum of square of x component. X component here is minus 3, y component is 0. So square of x component and y component. Y component in this case is 0. So it becomes root of 9, which is 3. Keep it in mind, the magnitude being the length should always be positive. Magnitude should be always positive. It could be 0, but in that case vector is like 0 vector. Okay, to simplify further, let's do question number 10. In question number 10, he's asking to find magnitude of f plus 2b vector. First of all, we're going to calculate f vector plus 2b vector. F vector is this one, x value is negative 3, y value is positive 6, plus 2 times b vector, which is this one, x value 4, y value 1. If we simplify further here in this area, we get here negative 3, 6 plus scalar multiplication here. 2 gonna enter inside the matrix or the vector to multiply with each of the component 4 and 1. 2 times 4 is 8. 2 times 1 is 2. So we get here vectors addition. Negative 3 plus 8 is positive 5. 6 plus 2 is 8. So this vector basically is f plus 2b vector. The target was to find the magnitude, the length of this vector. Length of this vector is like this, f plus 2b vector magnitude, and this vector is this one. So square root of sum of squares of square of x component and y component. X component is 5, y component is 8. So 5 square is 25, 8 square is 64. We get here 89 root 89 basically. So that's the answer to this part. So likewise, we can use the definition of magnitude to find the length of any kind of vector. So you can solve a variety of questions in this exercise. I will deal with some typical problems on this topic of finding the magnitude of a vector or writing a vector as a matrix, column matrix in the future videos. Okay, I hope you guys understand.